Hello everybody, this is Edward and welcome to a my tutorial about on rigging chords for a mechanical type of character or a structure. And what we're looking here is sort of our final result, something what we are planning to get at the end of this tutorial. It's going to be a very simple rig. The chord animation is not dynamic, it's manual. We're going to create a couple of controllers that will allow us to easily control and pose our chords the way we like it. So let's get started. What I'm gonna do is actually open up a beginning model here, a beginning scene, which is very simple. We have basic joints here just to control sort of the I don't know, the torso, let's say, and the pelvis. And here is our chord. These objects just are simply parented to the joints. We're not doing any skinning here, so just a simple parenting. We're gonna start with actually creating a curve to be able to control and bend our chord right here. So in some cases we may be actually be able to use history if we have extruded the surface along the curve. But let's say that we just decided to model it first, and then we decided that we're gonna animate it, and we don't have any construction history on this surface. So what we're gonna do is we're gonna come up to create CV curve tool, and we're gonna create couple of just a very simple curve. So we're gonna start at one end, create couple of points here. I'm trying to create these 2 points to create a nice tangency with the surface of this torso shape. And here we're gonna create couple of points here, maybe 3 points, just to get the proper curvature here. Again, we don't want to do too many points because then we might need extra number of controllers. We want to definitely adjust our CVs here just to make sure that we've got the proper alignment. We want this curve to actually run pretty much inside of this chord, just like that. Alright, I think that would do. And just as a habit, let's go ahead and delete any history that we've got here. Remember that if you want to do that often, if you're not going to be using that for animation. So the next step would be to create a wire deformer. What we're gonna do here is come up to the create deformers and click on the wire tool. You can actually see that Maya right here prompts us to select the surface. So just follow that, select the surface, hit enter, and you can see that the next thing Maya is asking us is to select the curve. And let's just do that. Select the curve, hit enter, and now we basically have done it. Right now our curve is controlling our surface. All we need to do is grab our CVs, and you can see that we have made a nice connection here. Everything is moving just fine. The thing is that we do not want to be animating CVs. We don't want to be animating components. We actually want to have a proper type handles. And what we're gonna do here is we're actually going to use joints. We're gonna create a couple of joints here. Let's actually hide our polygons, and just to be precise, let's display NURBS CVs, and we're gonna create our joints exactly where our CVs are. So we can point snap and create these two CVs, these two joints right there at the beginning, and these two joints at the end. And we're gonna create a separate joint chain right here, and I'm just gonna simply duplicate this joint and point snap to the other CVs here. Then we can parent these joints in the form of a handle. So this will allow us to sort of control the middle of the curve from this area. Okay, now that we have all of our joints created, let's move on to the next step, and which is simply skinning our curve. We're gonna be grabbing all of these joints here, select curve, and we're gonna come up to the skin menu, bind skin, smooth bind. We're gonna make sure that we are binding to joint hierarchy because we just grabbed the parent joints, and but we do want to make sure that it skins to everything here. We're gonna make sure that we've got interactive just in case we need to paint, but probably not. And maximum influence we can set to 1 because we only want one CV to be assigned to a specific joint. It should not share any weight. Let's hit apply, and we're done with that step. So right now you can see how this controls our chord right here. We can do that. We can also grab this part and animate these ends and the tangency here, but usually these parts are gonna stay the way they are. We're not gonna animate them. The only thing that you would want to adjust is this part of the curve. So we're almost done. What we want to do next is simply take these joint and parent it to kind of the spine. Take this joint, parent it to the hip joint, let's say, however you are planning to rig it. So now what happens is that when we are rotating the spine, it takes one end of that chord and keeps it with it, because we have created this tangency. It sort of preserves, and you can see how the chord is coming out. So same thing is happening right here. And now the next step is to make sure that this part of the chord sort of follows. We still want to have a manual control over that, but we also want to have this joint to generally follow the rig. So what we're gonna do here is we're gonna create a locator, just to make a sort of a different type of object here. We're gonna place it right here. Doesn't matter actually where we place it, because what we're gonna do is we're gonna create 2-point and orient constraints. So we're gonna grab this joint, shift select the locator, and say create or constrain point. We're gonna do the same thing to the other side, constrain point. So this at this moment we've got this locator. It's always going to stay in between these two joints no matter what we do, just like that. But we also want it to orient, because notice that it sort of just stays upright, and if we just gonna take this joint and parent it to the locator, it's going to move with it, but it's not going to orient with it. So let's go back before we parented it, and let's take the locator and also apply an orient constraint. Okay, so now it's not only following it, it's also gives us an in-between angle. The next step would be to, we don't want to just simply take this joint and parent it to the locator. However, we could do that, but just for a cleaner setup, what we want to do is create a curve as a handle, because one thing about the joints here is that we cannot freeze the translates of the joints, and if we're gonna move this joint, we're never gonna be able to find the default position. So what we want to do instead is create some kind of a handle. Let's just grab a circle, just point snap it right here. Let's rotate it 90 degrees, scale it. That looks right. And let's go ahead and freeze that. And we're gonna go ahead, actually probably first would be better to parent it. So now this curve is actually parented to our locator. It gets all of its coordinates from the locator, so it makes sense to freeze that one more time, just like that. Notice that right now we can go along the axis of the locator, up and down or in and out. The 0 position is now defined, and all we need to do is just take this joint in the middle and parent it to the curve. That's basically it. The primary thing here is set up already. So if we're gonna hide our locators, and we can actually hide our joints, but let's go ahead and test this out. So now if I grab the torso joint, we can see how this thing is following, sort of staying with the joint in the middle, or this controller stays in between the rotation of the upper and the lower body. And we just need to sometimes make additional adjustments to make our chord look nicer and more interesting, just by rotating our curve and keyframing it. So I hope that made sense. Of course, there are a couple of other things that could be done to that, and we would create controllers for the upper body, so we're not directly selecting our joints. But I hope overall that made sense in terms of how to do a basic setup and rig some basic chords for our robotic type of character or model. Thank you guys, and I hope to see you in the next video.